Hello, this is problem 23 from this national exam. In Lisa's mathematics book, there is the following problem. The figure shows the curve y equals to a sine x squared plus b. Determine the constants a and b. This is how Lisa solves the problem. She writes a equals to 1 minus 2 over 2 equals to 3 over 2 equals to 1.5, and b is equal to 1 plus minus 2 divided by 2, which is minus 1 over 2, which is minus 0.5, and she answers a is 1.5 and b is minus 0.5. Lisa's solution is not correct. Help Lisa solve the problem correctly. That's a good idea to pause the video at this point and give it a try yourself first. Okay, as probably you remember from the lesson, Lisa's solution is correct if the function was actually this function, a sine x plus b. But now you see that I have a second power of sine. How this will affect the problem? Yes, you know that sine is minimally minus 1 and maximally positive 1. Okay, but this is no longer true for sine x squared, because sine x squared cannot be negative. Of course, it will not go beyond 1 again, so maximally sine x squared is still 1, but minimally it is equal to 0. Okay, so then it means that considering that a is positive for the time being, if I ask you what is the y maximum value, you will go to your function and say that because the maximum possible value of sine x squared is 1, and because I am assuming that a is positive, to maximize this, I need to choose sine x squared to be 1, and then y max becomes a plus b. Now, if I ask you what is y minimum, you would say that, okay, I want to minimize this function now. A is a positive constant. By my assumption, b is also a constant, so to minimize this function, what I can do is just to minimize sine x squared, and the minimum of sine x squared is 0, so if I put 0 instead of sine x squared, I just simply get b. This is the observation that I make. But now I can go and refer to the diagram and see what are the values of y max and y min. So you see the highest value of y is 1, and the lowest value is minus 2. So this means that on the one hand, this is the observation I made. On the other hand, by looking at the graph, I see that a plus b, which is y max, is supposed to be 1, and y min is minus 2. Okay, so this means that already b is found. B is minus 2, and if b is minus 2, I go to the first equation. Instead of a, I put minus 2 is supposed to be equal to 1. Then it means that a is equal to 3. Okay, but how should I know that indeed a is positive? Okay, so that's also not hard to see. So if a is negative, then y max will be b, and y min will be a plus b. Okay, but then y max will be 1, and y min, as before, will be minus 2. But then what will happen here, if b is 1 and I put it in the second equation, this becomes a plus 1 equals to minus 2, and a becomes minus 3. So you think that we are a little bit in trouble, so you might say that, okay, this is also an alternative solution. But be careful, this is not correct. The reason is that b cannot be equal to 1. How should I know that? This is also simple to know. You see that this point has coordinates 0 and minus 2, and it is on the graph. So it means that it will satisfy the equation of the function. So instead of y, I put minus 2, and instead of x, I put 0. So then it becomes a times sine 0 squared plus b. But sine 0 is just 0. So this means that minus 2 is equal to b. And this is, by the way, another way to find b, okay, which was this answer, and that is correct. So we already know b has to be negative. And it means that a cannot be negative, because assuming that a is negative gives rise to a positive value for b, but that is not correct. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.